All right, today we're doing a deep dive into the Google Pixel 10 Pro. We're going to tear down the tech and figure out exactly how this thing delivers AI that's not just powerful, but instant and private. The kind of AI that lives right in your hand, no server connection needed. Let's get into it.
So just think about this for a second. You hit stop on an hour-long recording and bam, right there on your screen is a perfect, concise summary. That's a real feature in the Pixel's Recorder app. But how on earth does it do that without sending your private conversation up to the cloud? Well, the answer lies in a complete rethinking of how AI is supposed to work.
For the longest time, AI meant one thing. Your phone sends your data to some giant data center, you wait, and then you get a result back. But that old cloud model has always had huge drawbacks, right? It's slow because you're at the mercy of your internet connection, your private data is leaving your phone, and if you're in a dead zone, no AI for you. On-device AI just flips that entire script. The intelligence isn't out there somewhere, it's right here, with you.
So to really understand what's going on under the hood, we're going to peel this back layer by layer. We'll start with the big idea of AI living on the device. Then we'll get into the silicon itself, the Tensor G5 brain, and talk about why Google's approach is more of a marathon than a sprint. After that, we'll check out LiteRT, the software that conducts the whole orchestra, and see how Android itself has become a central hub for AI. And then we'll put it all together to see what this future in your pocket really means. So, what is on-device AI? Well, it's pretty much exactly what it sounds like. All the heavy lifting, summarizing your meetings, translating conversations, editing your photos, it all happens right on your phone's hardware. And the most important part, your data, your voice, your pictures, your messages, it never ever leaves your device. That means it's faster, way more private, and it just works all the time. And the engine making all of this a reality is Google's brand new Tensor G5 chip. Now, this is a huge deal, because for the first time, this is a chip designed completely in-house by Google. They've moved manufacturing over to TSMC, the undisputed leader in chip making, to build this thing from the ground up with one goal in mind: running AI efficiently. Okay, now you can look at the specs here and see the jump from the G4, but the numbers don't tell the whole story. The real magic is in the CPU design. See, instead of the usual 2 mid-cores, the G5 has 5. Now, that's not a setup designed to just win a quick benchmark. No, this is a design for handling lots of complex AI tasks all at once, without draining your battery. It's built for multitasking intelligence.
But honestly, the CPU isn't even the main event here. The real star of the show is the 4th-generation Tensor Processing Unit, or TPU. This isn't a general-purpose processor, it's a piece of silicon designed to do one job and one job only: blaze through the math that powers neural networks. And this new one is packing up to 60% more power.
So how does the TPU get to be so fast? It uses a clever architecture called a systolic array. The best way to think about it is like a huge grid of tiny calculators. Instead of each one slowly fetching data from memory, the data flows through the grid like a pulse, like a heartbeat. Every single tick, every calculator does its job and passes the result to its neighbor. It's an unbelievably efficient system for the kind of math AI relies on. Just to put some numbers on that, we're talking about the TPU's systolic array performing over 65,000 of the fundamental AI calculations in a single tick of the clock. That's not a typo. That massive parallel power is how your phone can do things that used to require a server farm and do them almost instantly. So we've established it has an insane amount of power. But raw speed isn't the whole story. And this is where Google's philosophy with the Tensor G5 gets really smart. They didn't design it for a 10-second race. They engineered it for sustained performance over the long haul. And this quote from Applevery just hits the nail on the head. The goal isn't to post some crazy benchmark score that you can't actually use in the real world. The goal is to run complex AI for minutes or even hours without turning the phone into a hot plate and slowing to a crawl.
And this chart, wow, this chart tells you everything you need to know. Look at that. Under a heavy stress test, the Pixel 10 Pro holds on to over 95% of its peak performance. The competitor? It has to throttle down to less than half its power just to keep from overheating. This stability is the secret weapon. It's what enables things like real-time video effects or even mission-critical industrial apps that need to run AI models reliably for an entire 8-hour shift. That's the kind of thermal endurance we're talking about.
Okay, so you have this amazing custom silicon, but how do apps actually use it? Well, that's where LiteRT comes in. You can think of it as the conductor of the orchestra. It's the essential software layer that tells the AI models how to run on the Tensor G5 specialized hardware, creating what you might call a tactile edge architecture. where software and hardware are in perfect sync.
For developers, LiteRT makes a super complex job much, much simpler. They can basically take an AI model, have LiteRT optimize it for the Pixel's hardware, and then just run it. LiteRT is smart enough to figure out which part of the chip, the TPU, the GPU, or the CPU, is the best tool for each specific task. And LiteRT is packed with some really clever tech. That compiled model API, that's the brain that automatically picks the right tool for the job. But something like zero-copy interoperability is a true game changer. It lets the chip process video directly from the camera sensor without slowly copying data all over memory. It completely eliminates a huge bottleneck, which is critical for any kind of real-time AI.
Now let's zoom out one last time to the final piece of the puzzle. Because this isn't just about the chip or the software framework. The Android 16 operating system itself has been fundamentally re-architected to treat AI as a core service, just like it treats Wi-Fi or your notifications.
And this is a massive change. The old way was just wasteful. Every single app had to include its own huge AI model, which ate up your storage, drained your memory, and was just wildly inefficient. With Android 16's AI core, there's just one highly optimized central AI model, Gemini Nano, that runs as a shared system service. Apps can just tap into it whenever they need to.
And this Gemini Nano model is seriously capable. It has what's called a 32,000 token context window. What on earth does that mean for you? It means the AI has a much, much bigger short-term memory. It can hold the equivalent of a month's worth of your emails in its head at one time, which allows for some incredibly powerful and personalized assistance.
So let's put it all together. What Google has actually built here is a fully vertically integrated system. You've got the custom Tensor G5 chip designed for a marathon. You've got the LiteRT software conducting the AI tasks. And you have the Android AI core managing it all at the system level. Every single piece is designed to work in perfect harmony with the others. And for you, the person actually using the phone, this all boils down to 3 huge advantages. 1, true privacy, because your sensitive data stays put. 2, instantaneous response, no waiting for a server. And 3, sustained performance, which unlocks powerful AI that can run for hours, not just a few minutes.
This tight integration of hardware and software creates an AI that's truly personal. It's an AI that can learn your patterns, understand your world, and help you out, all while keeping your life's data completely private and secure. It's a fundamental change in what we expect from our devices, and it really leaves us with one big question to chew on. When your phone's AI is this smart and this private, what's even possible next?